You must know this. This is the whole electromagnetic spectrum. And we are interested from what is 10 minus 10? 1 angstrom. And when it is 10 power minus 8, it is 100 angstrom. Is it 10 power minus 8? 100 angstrom. When you go a little bit up, that will become about 80 angstrom. So from 1 angstrom to 80 angstrom are the dimensions of most of the crystals. The dimension, the latest parameters, the ABCs of most of the crystals come from 1 angstrom to 80 angstrom. And that is why X-ray is the ideal technique for X-ray crystallography, for determination, for phase analysis, for crystal structural analysis of materials, right? I told you that the X-ray is used because the dimensions of unit cells are comparable with those of the wavelength of X-ray. If the wavelength of X-ray is above that, then it will be like that you are measuring the dimension of key with the meter rod, or picking rice to your mouth to the through a tractor blade, right? So it must be comparable, and that is the main reason that people do it. I'm sequentially going. The tube, X-ray tube, is vacuum. You send, you electrically heat the filament, and it ejects electron. You apply a potential difference between the target and the emitting electrode, right? So the X-rays are produced when high-speed electrons hit the metal surface. That is how you get X-rays. But when you hit the metal surface with electrons, it will emit X-rays in every direction. It will be like a shower of radiation around, right? Then it is the similarity with optical interference. It's for those who doesn't know anything about diffraction, right? That when the two waves have zero path difference, then they will go together and they will reinforce each other, and only constructive interference will occur. Here, there is complete destructive interference, and wherever the path difference between the two waves becomes integral multiple of the wavelength, then again this speed reaches here. If the path difference is a wavelength, or two wavelengths, or three wavelengths, then this speed will reach here, this will reach here, and in this way it will be constructive interference. So the X-ray diffraction theory is basically based on this very simple principle. But if you go out of this class, at least you should have no question in mind regarding X-ray, right? Because I saw many people delete their X-ray results from their presentation, that if Yaseen is sitting there, then he will ask questions. So it is the simplest thing one must know in material science, right? That is why I am sequentially going it. So diffraction is the scattering of a coherent wave by the atoms in a crystal. Diffraction pattern is the result of the interference of the scattered waves. Now, when I told you in the start that when the cathode emits electrons and it through the potential difference, they are not going on their own, right? The potential difference accelerates them towards the target. When the X-ray come from there, they are going around in every direction. And to consolidate, to combine that beam together and select the ones which you need for the analysis of crystal structure must be monochromatic. Because if they are not and your wavelength varies, then your n lambda 2d sin theta is equal to n lambda, and if this lambda is variable, then it is of no use. Similarly, again, to concentrate the beam onto the desired crystal planes to a sample, you again put the slit before the detector as well, so that the randomly scattered X-rays go away. If a shower is coming like that of electron beams, then everywhere there will be diffracting, and even the diffraction events will be so many that it will become very difficult for you to resolve them. That is why you need in X-ray, people use small slits. The drawback of small slit is that it decreases the intensity of your pattern. So, if it decreases the intensity by 5%, right? Then what happens? Your 100 peak become 95. Similar and come down. So your 5 peak will be 0. So you lost that peak. Right? There are always positives and negatives of applying different conditions. An electron microscope, the two-beam condition. The two-beam condition means that they select one transmitted beam and one diffracted beam to contribute to the image. Because when you focus the electron beam upon the sample, you are heating the sample. And if the sample is volatile, then the material is not stable under the beam. So all these precautions are included when you are conducting an experiment. So look into these definitions, that diffraction is the scattering of a coherent wave by the atoms in a crystal. And diffraction pattern is the result of the interference of the scattered beams.